All right, so now that we know about moles and we know about molar mass, we are going to do some calculations using molar mass. So 7.3 is calculations using molar mass. The learning goal is given the number of moles of a substance, calculate the mass in grams. Given the mass, calculate the number of moles. So we're going to go between moles and mass. All right, so molar mass, just a review from our last notes, it's a useful conversion factor. Because molar mass tells us how many moles of a substance is, how many grams that is, and then what the mass in grams is, how many moles does that give us. So last section we learned that you could do from an element like magnesium here, you could figure out what its molar mass is. So 1 mole of magnesium has a mass of 24.31 grams, and that comes straight from the periodic table. So anytime we have an equality, that gives us a conversion factor that we can write as a fraction. So here's our fraction, 24.31 grams of magnesium is the same as 1 mole of magnesium. 1 mole of magnesium is the same as 24.31. All right, so silver metal is used as a manufacturer of tableware, mirrors, dental alloys, and jewelry. If the design for a jewelry piece requires 0.750 mole of silver, how many grams of silver do we need? All right, so this is where we're going to go back to using our cups method. So my known. I know the number of moles, so 0.750 moles of silver. Silver is Ag. Okay, that's my known. My unknown is I want to know how many grams. And just like we did in 7.1, our plan is going to be a conversion factor, a fraction. So the plan here, we're going to need to know how many moles, or how many grams is 1 mole of silver. And we always put what the known unit is down in the denominator because we're going to want to cancel that out. So I'm going to have 1 mole, and then I need to look on the periodic table to find the molar mass of silver. So I find silver and it says 107.868. And so that's grams, it's the weight, the molar mass of 1 mole. And so to solve this, we need to convert my 0.750 moles of silver to grams using this conversion factor. So we're going to put our known up in the top left, 0.0750 moles. I'm going to put my moles down here, which is 1 mole, and I know the atomic or the molar mass of silver is 107.868 grams. Cross off my moles, multiply across the top, pull up my calculator. 0.750 times 107.868, and I get 80.901. This has 3 sig figs. This has 1, 2, 3, 4, 5, 6. So my answer can have 3 sig figs. So I'm going to go with 80.9 grams for my how many grams of silver is in 0.750 moles. Okay, these just go through the problem again if you want to look at it. All right, so then for compounds, that was an element. Silver is obviously an element. If you have compounds, you have to find the molar mass of that compound. It works the same way though. So 1 mole of H2O has a molar mass of 18.02. You get that by adding 2 hydrogen molar masses with 1 oxygen molar mass, and that can give us conversion factors as well. Okay, so first you want to figure out what is the conversion factor, and then you can use it to convert. So let's try one of those. A box of salt contains 737 grams of NaCl. How many moles of NaCl are present in the box? So we need to use our cups method again. So let me erase what I had before. So my known is the mass. So I know that we have a mass of 737 grams of NaCl. Okay. My unknown is I'm looking for how many moles. My plan is going to be how many moles, or how many grams is 1 mole of NaCl. Well, I'm trying to get rid of grams, so grams are going to go in the bottom. 1 mole is going to go in the top. Now I need to figure out what is the molar mass of NaCl. To do that, I need to look at the periodic table. So Na has a mass of, and I'm just going to do this off to the side, 22.98977. There's only one Na, right? And then Cl has a mass of 35.4527. Okay, so that's Na and Cl. I'm going to add those together. So 22.98977 plus 35.4527. Remember, we round that to the nearest hundredth, so I get, and remember this is just side work that I'm doing over here, I get 58.44 grams is the mass of 1 mole of sodium chloride. So I'm going to put that right here, 58.44 grams. And that's my conversion factor, that's my plan. So now for my solve, I just draw my t-chart, put my known in the top left corner, 737 grams. Grams need to go down here, so they'll cancel, so I just use this conversion factor that was my plan, 58.44 grams to 1 mole. Okay, so then I multiply across top, 737 times 1 is just 737, and I'm going to do that divided by 58.44. Whoops. And I get 12.61122, so I got to look at how many sig figs. Well, I have 3 sig figs here, 4 sig figs here, so I'm going to go with 3. So 12.6, and let's see, the grams canceled, I'm left with moles. 12.6 moles is the number of moles in a box of salt. All right, if you need to go through that again, you can watch the video again, or you can go through these slides. They talk you through how to get that. All right, so summarizing our conversions, we did a lot in the past few days. So if you have mass in grams of an element, okay, or you could have grams of a compound. So mass of an element would be like silver we just had, and then grams of a compound would be like salt. You can use the molar mass to go to moles, okay, and then you could go in between those to go from the element or the compound looking at the subscripts. But if you're already at moles, then you can go to particles. So how many atoms I have or how many molecules I have. But no matter what, you have to go through the moles. And so what some chemistry teachers call this is mole island. Okay, and don't worry about this bottom right side. We're just going to focus on the mole island, which is right here. But if you have an atom, and you know how many atoms or molecules I have, you can figure out how many moles you have. That's what 7.1 was. If you have the mass, you can figure out how many moles you have. That's what 7.2 was. And so now we can go in between grams and atoms, but we have to go through mole island, okay? Can't jump straight from over here. There's deadly animals in the water. You got to go through mole island. All right, don't worry about liter island yet. We haven't gotten to that. And if this whole thing just confused you, ignore me. But we're going to go through this. You have to go through moles is basically what I'm trying to tell you. Okay. Same kind of thing here. If you have your grams, you can go to the moles. If you have your moles, you can go to the atoms, but you have to always go through the number of moles. All right, so let's try one of these. A 10-pound bag of sugar contains 4,536 grams of sucrose, C12H22O11. How many molecules of sucrose are present? So this is going to be a multi-step problem because we're going from grams to molecules. And so whenever you're doing that, you got to go through moles first. So my known is the mass. So I know 4,536 grams. Okay, my unknown is how many molecules. My plan, I'm going to need 2 conversion factors. So first, how do I go from grams to moles? And then how do I go from moles to molecules? So first, to go from grams to moles, I need grams in the bottom, moles up top. So 1 mole, and then I'm going to have to know the molar mass of sucrose. So I'm going to cheat and I'm going to look further up in our slides because I feel like we probably talked about what the molar mass of sucrose was, but you could calculate it, right? You should know it. And so this slide shows us that the molar mass of sucrose is 342.3 grams. So 342.3 grams. If you don't know how to calculate that, you need to go back and redo those notes, okay? Where are we? We are right here. Okay. So if you don't know how to do that, that's one. So that'll get me from grams to moles, and then I need to go from moles to molecules. So I'm going to put moles in the bottom. And we know from moles to molecules, we use Avogadro's number. So 6.022 times 10 to the 23rd. So those are my 2 conversion factors, so that's my plan. So now I just need to turn this into a t-chart. So my t-chart's going to have 2 parts. It's going to have a beginning and a middle and an end. Okay, so I put my known right here. So I'm going to kind of move my S over a little bit. 4,536 grams. Okay, and then I use that first conversion factor, so 1 mole and 342.3 grams. So those grams will cancel and I'll be left with moles. And then I'm going to use the second conversion factor, 6.022 times 10 to the 23rd over 1 mole. The moles will cancel and I'll be left with molecules. So now I multiply the whole top and I divide by the bottom. So let's do that in our calculators. So you do 4,536 times, and then we're going to use parentheses because we've got a number in scientific notation, 6.022 times 10 to the 23rd. Okay, see I've got that in parentheses. I'm going to say equals, and then divide that number by this one in the bottom, 342.3. And I get this huge number, okay? So I'm going to move the decimal place over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 24. So 7.9. And I need 4 sig figs. So 7.980 times 10 to the 24th molecules in a pound or a 10-pound bag of sugar. If I just confused you massively, go through the steps again, prove that you understand how to get this, okay? The big part of these notes is this part, knowing that if you have grams, you can find out how many molecules or atoms. You have to go through moles though. Okay, so figuring out where you start, where do I need to go, what conversion factors do I need to know to get there. Okay, we're going to practice these, but if you need to rewatch this video, go ahead and do that. All right, toodles.